Hello everyone, my name is Kijin An from Virginia Tech. My advisor is Professor Tulivich in CS department. Um, in my dissertation, I'm studying a problem of distributed web applications in a perspective of software engineering. The title of today's presentation is Enhancing Web App Execution with Automated Reengineering. I have mainly two contributions for my dissertation. The first contribution, I introduced a new type of refactoring, client insourcing, which integrates some remote functionality into the client. It transforms a distributed web application into a centralized applications. This is a refactoring because it preserves the semantics of the original applications. This work is going to be published to the web conference this year. The second contribution is to demonstrating the value and the utility of current insourcing. It turns out that current insourcing has a value. This approach can optimize, evolve, and maintain many existing distributed web applications. This is my second contribution. The execution of a modern web application is affected by distribution. This is a device. Initially, it was a zero distribution, and this is a cloud server. And there exists many design choices for distribution. Application functionality can be enhanced by means of uploading some functionality to the cloud server. However, distribution has some costs, such as communication overhead and partial failure. So what if the distribution is conceived? How to re-engineer distributed application to fix this kind of problem? For instance, what if the bugs are in a distributed application? How to fix it? The distribution complicates the debugging task. In some cases, a distribution can be ill-conceived in terms of granularity of remote service. Um, the reality of runtime for distributed web application can be far from the design time. In running environment, the network condition can be very limited, unlikely to the design time. To evolve distributed applications, I propose a new type of refactoring, client insourcing. This refactoring undoes the distribution. To that end, the client insourcing identifies the functionality in a server program, and it moves this part into the client program to integrate the rest of the program in client. After that, client insourcing create centralized applications. We can say that this centralized version is semantically equivalent because this operations only changes the locality of execution without any modification of the application functionality. Our main idea is to modify or enhance the distributed web applications. Is done in this centralized variant. Intuitively, analyzing and modifying the centralized version is much more easy since many state-of-the-art tools and the technologies are based on the centralized applications. This is a new approach for evolving distributed applications. The domain of our approach is full-stack JavaScript web applications. The server and the client code are written in JavaScript. Client insourcing render centralized code for these applications. It means that The client insourcing should identify the entry-exit point for remote functionality without the middleware logic. And second, to render a locally invocable function, client insourcing should search and copy all dependent code for the remote functionality. To be specific, to identify the entry-exit point, client insourcing apply a dynamic analysis. It instruments the HTTP traffics and the read-write event. Also, client insourcing apply a declarative analysis by means of constraint solver to search all dependent code on the identified entry-exit point. Next, I'll demonstrate applications that can use client insourcing refactoring. First application of client insourcing, catch and release. Uh, uh, this catch and release can automatically debug distributed web applications. Distributed applications can have a bug. However, the problem is that debugging tools are applicable usually applicable to the centralized applications. So this approach inspects and fixes memory, weak or performance bottleneck in the centralized variant. After that, this tool generates patch based on the fixed path in the variant. The second application of the client insourcing is called the Goldilocks. A small distribution that incurs a low overhead, but can take a long latency, whereas a large number of distribution incurs many overhead, as shown in the below. So between too small and too much distribution, the Goldilocks determines a right boundary of remote execution and the right number of remote executions. First, the Goldilocks applies client insourcing and then apply partitioning operations to find the independent subset of this variant. Then this tool explores all possible distribution by means of the matching remote invocation. That is kind of refactoring for centralized application. The Goldilocks define a cost function to determine the optimal distribution, and then this tool find the minimum cost distribution. In design time, the application consider the good network. So, however, in runtime, the application executed in a poor network, and the mobile device can have a powerful resources. In these conditions, application functionality can be executed in a device rather than the remote server. The remaining work, we propose an adaptive redistribution framework that dynamically assigns the functionality based on the network condition. Similarly to the mobile computing, we are extending our approach to edge computing. In runtime, cloud network can be limited in reality. Then the server data deluge can significantly cause a performance problem. Edge computing is a solution as edge node and the device can produce and consume data in a fast edge network. To that end, cloud device two-tier architecture needed to be transformed to three-tier architecture, including the edge node. However, this automated refactoring has not been studied a lot. Our approach to client insourcing can automatically insource application functionality over the cloud server into edge node to enable such kind of edge service. To conclude, we introduce a new type of refactoring client insourcing. In this presentation, I briefly demonstrate the value and utility of this refactoring for optimizing and maintaining tasks for distributed web applications. Thank you.